Today, around 6 participants. They'll join slowly. Let me. So, last class we are discussing something about a lot of things. Plug flow reactor, and we got the design expression, right? The design expression for a plug flow reactor is this. Tau by tau by C A naught is V by F A naught integral this particular this fellow, and that question I put is almost this is similar to batch reactor, right? Similar to batch reactor. I asked why this performance equation is same. So you might have thought about it. I think some people, I think Arun, I think, sent a mail to me. It's good what Arun gave. Uh, Now, can you explain, Arun, what you wrote in the mail? Yeah. Now, can you explain to all the class? Arun, you are there, I think.
Arjun, sir.
Is it Arjun or Arun? Arjun Raj.
Arjun, I sir.
Okay, I got it wrong. Night I sleeping, I just saw. So I thought it is Arun Raj. Earlier there is one boy named Arun Raj in some of your seniors. He's very close to me. So suddenly I thought your name is also Arun Raj. Good. Sorry for that. Your name is Arjun. Okay. Arjun. Yeah, go ahead. What you.
Yes.
Uh, Go ahead. What is the question you answered and what is the answer? Yeah, both. So that other people also will know. Yeah, go ahead.
So the question was like why the time expression came out same for both batch and continuous reactors.
One correction, it's not a time expression, it is the performance equation, right?
Okay, sir.
Okay,
Performance
performance
equation.
equation in the sense either you can calculate the volume or the time required. Okay, yeah, go ahead.
Yes, sir. The performance equation came same because uh, the time that in a continuous reactor we are calculating it in terms of space time. So it is a time we are required for processing one reactor volume of the feed, that is calculating the space time when a particular reacting volume is there in the reactor and the time taken for that to convert, that is the space time that we are calculating it for continuous reactors, and in that case we are not considering about the inflow and outflow. We are calculating it only for that particular volume in the reactor. Same way only we are calculating it for batch reactors. So I thought that the expression came out same because of this reason.
One correction I like to add to you, is it continuous reactors or only plug flow reactor? Because continuous CSTR and plug flow, both reactors are continuous. So you are talking about continuous reactors are having the same expression as batch reactor. Is it continuous reactors or only CSTR or a PFR, a particular set of reactor? Yeah.
PFR only, sir. Sorry, sir. Only.
So don't use that term that a continuous reactors. It is only PFR.
Okay.
Continuous in the sense CSTR also will come into picture. Whereas CSTR, the design expression is different. You won't get this integral at all for that. Only XA by minus RA you get, right?
Yes, sir.
Yeah, how many people satisfied with this answer? How many people satisfied with this answer? Is it okay? Yeah. Is it okay? You understood what is that? Yeah. The answer is correct. I don't want to give the detailed still answer. Still, I'll hold for some more time. So answer is correct, but given a proper, he gave absolutely correct, but does it make sense? Does it make sense? This argument, does it make sense to you? Yeah, he might have taken from some internet or something like that. Okay, internet, you will get n number of answers, but that answer, whether you are convinced, or is there any other way you can understand much better? That is what is more important, right? So still, I keep that option open. You discuss with your friend, right? The other question I asked, no one answered anything. There are two questions posed. One question is this Arjun Raj, what he's telling. The other question, the other question, why the volume required for PFR is much lesser than the PFR, right? So you can see here, I'll just show you. Forget about this. I'll just, yeah, now this is going to be the XA what you want. And if this is the rate expression, you are drawing minus RA versus XA. This is the initial. Generally, let us go from 0, or it is having some converted. So area under the curve will give you tau P by CA naught. That is nothing but space time of a plug flow reactor. Whereas for the same conversion, the rectangle area will give you for tau M. That is nothing but tau M or P suggests it is mixed and plug flow, right? So just to differentiate, they put tau M by CA naught or VM by FA naught, whatever you want to name it. So he is giving only in terms of taus. So the volume of or the space time required for the CSTR is much greater than PFR, right? So no one answered this question. Why? Why, man? Okay, let us keep that question still open. Just think about it. Why it will be like that? Though both are say continuous reactors, in one for the same conversion, your area of or area or volume or tau for a mixed flow reactor is much greater, right? So think about it, and then we'll start today. Some problems we'll do so that. Because already I gave assignment. So let us do some problems so that you can start doing the assignment. Then we'll go for one more set of reactors, that is mixed reactors, not mixed reactor. It's a recycle reactor, which we'll discuss in the next class. Okay, this is also a very important reactor. Tomorrow, by the way, keep a note. Tomorrow I'll be taking the first hour. My period, that is 4th hour, will be taken by mass transfer, right? Because I'm having some work tomorrow afternoon. So I just shifted. So please join me for the first hour and 4th hour for mass transfer. Okay. Guru, is it okay, Guru? Guru or Yamini? So tomorrow
Yes,
alone.
sir.
Okay. Tomorrow alone, I'm having some work in the afternoon. One more request is, yeah, you are telling that Saturday 11 o'clock or something you are free to you gave me time to take the class Saturday, right? Saturday I'll take, but this Saturday I'm having some work. I'm going somewhere out because it's a holiday here in college. So I'm having some assignment which I have to go out. I'll be driving at the time. So I may not take on Saturday. I may not take on Saturday, but next Saturdays I'll try to take. If possible, can you give the third Friday last hour where it is some mentor hour or something like that? If you are free, then we can take instead of Saturdays or something, regular days. If you are interested, then I can request the HOD or something like that. Because some 1 or 2 extra classes I'll be taking. Okay, that you decide. And other than that, Saturday also I'll take when it is a working in the college, I'll take. If it is a holiday, then I may be having some other work in my home, something like that. Because I'm not having a regular laptop also in my home, so I have to come through the cell. So it becomes much difficult to take through the cell, right? One second, just 5 minutes. One minute. ஒரு 9:30க்கு வரீங்களா க்ளீன் பண்ணுறதுக்கு இதுக்கு கிளாஸ் எடுக்கிறேன் என்ன கூட்டு வைங்க நான் வந்து கொடுக்குறேன் அங்கே வைங்க எத்தனை கொண்டு வந்துங்க சரி இருக்கு நான் வந்து கொடுக்குறேன் ஒரு 9:30க்கு வாங்க. We are discussing about this recycle reactor. No, not recycle. I'm talking something. What I'm talking about. What I'm talking?
Saturday.
Saturday. Yeah, Saturday we'll try to take, but this Saturday it is not possible for me because having some other work. So we'll see. I'll Saturday I'm taking. I'll just send a message. But next Saturday onwards we can, because college is working at the time. Okay. So let us do some problems so that we get comfortable. So this is an exercise example problem in Lebenspiel, which is very popular. This a lot of times they asked in the exam. Just it's a worked out problem. Just we'll see what is it. Okay. If you want, you can write. I'll just go through this. No need for me to write something on there because it's all worked out. It's a neat what they give. We'll just see some 2-3 problems today, right? So that you can start doing the tutorial problems because the time I gave is 31st. Okay. So let us see the problem. I'm just reading the problem. 1 liter per minute of a liquid containing A and B. So Ca naught is this much and Cb naught is this much, flows into a mixed flow reactor of volume 1 liter. The materials react in a complex manner for which the stoichiometry is unknown. So stoichiometry is unknown. That means that what is K and what is N, that is the order of a reaction, is unknown. Yeah, the outlet stream from the reactor contains A, B, and C. So C is the product, right? C is the product. So A and B are the reactants, and the outlet contains A, B, and C. That means some unreacted A, some unreacted B, and the product C. So which is having a concentration CAF is 0.02. CBF, that is concentrations is giving, and CCF also concentration is giving, as shown in this reactor. Find the rate of reactions of A, B, C for the conditions within the reactor. This is what he is giving you. You can see the diagram. Liquid, this is a mixed flow reactor. That is what he is giving. So a mixed flow reactor, which is having a stirrer to stir the content so that the concentration will be uniform at any particular time. That means there is no, if you take a molecule here or here, anywhere, that is having the same concentration. The volume is giving you 1 liter. Then volumetric flow rate he gave you 1 liter per minute. That means it is the volumetric flow rate V0, that is inlet flow rate is 1 liter per minute, and is giving you initial concentration of A and B. Ca naught is 0.1, Cb naught is 0.01, and he is giving you the outlet concentration. Ca or CAF is 0.02, Cb or CBF is 0.03, and Cc or CCF is 0.04. Cc is 0.04 in the sense Cc naught here it will be 0 because initially there is no reaction. So for these conditions, he is asking you the stoichiometry is unknown. Stoichiometry is nothing but minus Ra is K into Ca power N. So K he don't know and N he don't know, right? So he's asking you find the rate of a reaction minus Ra. How to do this? Now this is a mixed reactor. This is a mixed reactor. He gave you volume and he gave you volumetric flow rate. So volume is given, volumetric flow rate is given. You can calculate tau. Tau is nothing but volume by volumetric flow rate. So 1 divided by 1 will give you tau as 1. Now you know tau 1. We know that tau by Ca naught is XA by minus RA, because that is the expression, yeah, you can see here. For a liquid in a mixed flow reactor, because liquid is giving you, liquid means generally the expansion factor will be 0. Therefore, expansion factor is 0. Minus RA you can write as Ca naught minus Ca by tau. Correct, because tau by Ca naught is minus XA by minus RA. So minus RA is Ca naught minus Ca by tau. Tau we already know. Ca naught is given, Ca is given. You can write this. So minus RA is 0.008. Like that, RB, RC also you can give. Now this minus RA is positive. Minus RB is negative. Minus RC is negative. That means that RA is, you can see A is disappearing while B and C are being formed, because minus is minus, and if you take this positive, this also becomes positive. So the reaction here is A is giving you B and C. A is giving you B and C, correct? So A is disappearing while B and C are being formed. Otherwise, A is giving you B or B is giving you C. That is also like a series reaction also it can happen. So that is what he is asking you, right? So that is why he gave the stoichiometry is unknown, right? So you calculated minus RA, minus RB and minus RC, right? So from this we can tell one is reactant, whereas rest of the two things is the product. So it's a series reaction. A is giving you B, B is again disappearing to give you C, right? So one more problem, which this they will ask for 2 marks, but this they will ask for an essay question, that is 6 marks or 12 marks. By the way, I noticed one important thing in your exam paper. In the exam paper, if I am asking you some problem to calculate some rate or order or something, a lot of people just drew on the graph on the what do you call this paper. You have to draw the graph on a graph paper, then only you get the mark. So lot more than some 40 to 50%, even much more people didn't draw the graph. Okay, you might have did, or you might have copied from some book, but you just drew with pen on the paper. So you have to do that on a graph sheet. Then only you get the mark in the final. Any graph sheet problem you have to do in a graph sheet only. If you are doing normally on a paper, you may not get the mark. So that is one thing which I need to clear, because yesterday I was correcting, so I noticed a lot of people didn't draw the graph. Most of the people did well in the exam. Some people didn't write the essay question, the last essay question. Some 5 to 6 people didn't write that essay question. I don't know why. 1 or 2 boys, I think part A or part A, 12 marks multiple choice is more not given in that whatever you attached. So these are some of the things. The rest of the people is fine, because some people might have missed. I don't know. That's why I told you to write part A first and then part B, part C, go in order. But some people, they didn't write start with part A. They directly started with part B and part C and forgot part A. Some 2 or 3 students I found that. And some 5 to 6 students, they didn't write the last 17th question. That is the differential thing, right? For the differential method, differential method, you have to draw the graph and then find out the slopes at different points. So you just copied from some book what he gave. So for that, without graph, how you got that values? Yeah, right. So if there is a graph problem which they ask, you have to do the graph, right? Okay. Let us do this problem now. That is the what do you call the summary of the findings what I found. Rest of the thing just all the people just did well. Rest of the people is just straightforward questions. So that problems whatever I gave, a lot of times they asked in the exam. So you can expect some of the questions in the final, if at all it is going to be a descriptive, right? Pure gaseous reactant. So he is giving you gaseous. That means that you have to take the expansion factor into picture, right? So pure gaseous A, Ca0 is given 100 millimole per liter is fed at a steady state in a mixed reactor. So this is a mixed reactor. Volume is given where it dimerizes. 2A gives R. So the number of moles is reduced and it is a gas reactant. So definitely there will be expansion factor into picture. For the different gas flow rates, he is giving you the run number. V0 is giving you what is the volumetric flow rate, and CAF also is giving you. For this, find the rate for this reaction. Rate equation in the sense minus RA is K times Ca power N. So what is K and what is N? He is asking you to find out. So when he is giving you this kind of problems, whenever they give some experimental data like this, definitely you have to draw the graph. The exam, please make sure that graph problems you do in a graph sheet. So let us calculate expansion factor because he's giving you gaseous and 2A gives R. So he's calculating and he didn't give any inerts present or pure. So he himself is giving you pure. So that means that there is no inerts. So you can calculate the expansion as final minus initial by initial. 1 minus 2 by 2 is minus half, right? Because this is decreasing, that is why you get negative. So he is telling it is a mixed flow reactor, giving it is mixed flow reactor. V0 is given, that is volume is given, and then the volumetric flow rates are also given here, right? So we know that for a gas phase reaction, Ca by Ca0 is 1 minus Xa by 1 plus epsilon A Xa. If there is no gas phase, this epsilon A will be 0, then Ca by Ca0 is 1 minus Xa. Then Ca is Ca0 into 1 minus Xa. That is the expression which you got. So substitute epsilon A is half minus half. Then this comes like this. 1 minus Xa by 1 minus half Xa, or you can take still LCM 2 minus Xa here, and here if you multiply 2 minus Xa it will come, right? So Xa, we know that Ca by Ca0 is this. If you calculate Xa from this or Xa from this, Xa you can write as 1 minus Ca by Ca0 by 1 plus epsilon A Ca by Ca0, and substitute epsilon A is half, then you are left with this. Either you can do with concentrations or conversion, that's up to you, right? So I'm putting with the conversion Ca by Ca0 by Ca by 2 Ca0. Then what you have to do, he is giving you run, this runs. So whenever he is giving you like this some experimental data, it is always better to draw a tabular column. So we know that minus Ra, what do you call this mixed reactor? What is the expression for mixed reactor? Tau by Ca0 is V by Fa0 is nothing but Xa by minus Ra, right? So we want minus Ra. So minus Ra is V0 Ca0 Xa by V. We can write that. From the design expression of V by Fa0 is tau by CA naught is XA by minus RA. V by FA naught, FA naught you can write as V naught into CA naught. So if you rewrite this in terms of minus RA, you can get right this. P by, F by V into XA. F is nothing but V naught into CA naught. So he is giving you run. V naught is giving you. CA is also giving you. We need to calculate XA. XA you can put CA in this expression and then calculate XA, different XAs, because CA naught is constant, whereas CA is changing with respect to the time. So from that we can calculate XA. So for this particular runs, XA is this. Then minus RA is V CA naught by V into XA. So V first one is 10. CA naught is he is already gave is 100 into XA is 0.25 divided by V. V is nothing but the volume of the reactor, which is giving you as 0.1 liters. So everything you are putting in liters, right? So that's why V naught is also in liters. What he gave, V naught is in liters, right? So here, make sure that everything you are substituting the same values, right? So again, here also millimole per liters, right? So when you are putting liters, you put liters. When you are putting meter cube, you put here also meter cube. So make sure that you convert to the same unit so that it gets cancelled out. So minus RA is 250 because we need to calculate its kinetics. So we can calculate log CA, log RA, because we know that this expression log RA is log K into N log, because this is the expression which we need to have. We don't know what is K and what is N. So for calculating that, you take a log on both sides. Log minus RA is log K, N log CA. So once we calculate RA, we can calculate log minus RA like that log CA, right? So this on the y-axis, log CA on the x-axis, it will have a straight line, not passing through the origin. It will have an intercept and then slope. If you calculate the slope, you get N. And if you calculate the intercept, will give you log K. And the slope of this particular thing, this is what is calculating. Slope is 2. So the log K is K. K is 0.36. So from that, what we can get minus RA is K. K into CA power, right? N, right? So K is 0.36. You have the unit because you know what will be the unit based on this particular thing, right? So yeah, you can because CA unit, you know, minus RA unit, you know, based on that K and N unit, you can fix it, right? Either it is a first order or second order based on, since N is 2, the order is 2, K will have a unit of liter per hour millimole, because CA square minus RA will have a unit of concentration power 1 minus N into time power minus 1. So concentration power 1 minus N, N is 2. Therefore, concentration power minus 1, time power minus 1. So that is what you get for minus RA. So this is the expression for doing it, right? So either you can put in terms of whatever unit you want. So this is millimole per liter R. This is for minus RA unit, and this is for K unit. This is for reaction rate K unit. K will have a unit of concentration power 1 minus N, time power minus 1, right? So here one important thing is, he never gave whether it is a liquid phase reaction, or that is whether you have to consider this expansion factor or not. But the same problem, if you are assuming it is not, there is no expansion factor, and if you are taking Ca by Ca naught is 1 minus Xa, and Xa is 1 minus Ca by Ca naught, try to do it, then you get a different result. That is what here he is giving you. If we ignore the density change in our analysis, if you put epsilon A is 0, then Ca by Ca naught is 1 minus Xa, then we end up with the incorrect rate expression. Though you are getting N as around 1.6, but the performance predictions, everything will be wrong, because the you forgot about this particular thing, that it is a gas phase reaction. So gas phase reaction, you have to put this epsilon A. For a liquid phase reaction, you can eliminate this. For the same problem, if there is a liquid phase reaction here, then definitely your expression for this rate will be, that order will be 1.6, not 2. Understand? So everywhere, just when you are doing an problem, see to that whether it is a liquid phase reaction or a gas phase reaction. Yeah. Any doubt in this problem? This problem was asked for lot of times. This problem in a example problem in 5.2. This is the third edition of Levenspiel. They asked lot of times. Important catch is this. Some people miss this calculating epsilon A, because here gaseous component is given, right? The rest of the thing is you have to draw a graph. That's the big thing. So RA is this expression. We know V naught, Ca naught, because V naught into Ca naught is Fa naught. So V by Fa naught is Xa by minus Ra. So you rearrange that equation to give you this. Fa naught we are not putting because your volumetric flow rate is given. If he is giving you molar flow rate, then no need to have volumetric flow rate. You can put Fa naught by V. That's up to you, right? So he is asking you the kinetics. This is the thing which you have to go. You don't know what is K and what is N. He is required to calculate K and N. For this kind of thing, you take a log, then this becomes a linear equation. Then draw a graph, find out its slope and intercept will give you K and N. A simple problem. Try to do with the graph sheet, right? Again, I'm telling you, try to practice some 1 or 2 graph sheet problems with the graph sheet. You may think that graph sheets drawing is easy, but graph drawing is very difficult. It's not that easy. Again, I'm repeating. Calculating slope and intercept is fine, but if you want to calculate the area under the curve, especially for a PFR, you go definitely wrong, right? So please try to do it. We'll do one more problem on a mixed reactor. This problem is also very popular. He is giving you it is a reversible reaction. A plus 2B gives 2R. A plus 2B gives R. In elementary, he is giving it is elementary. That means that it is corresponding to the rate expression. Liquid phase reaction, A plus 2B gives R, is K1 forward reaction, K2 is the backward reaction. With a rate, he is giving you the rate also. Since it is an elementary reaction, it is a third order reaction because Ca into Cb square will come. Some noise I am getting, please mute yourself. Okay, thank you. So minus Ra is minus half Rb. How I am writing this? Can anyone tell? Ra minus Ra is half times minus Rb. That is the rate of disappearance of A and the rate of disappearance of B. Because the coefficients minus Ra by 1 is minus Rb by 2. Because coefficient. That is how you get. Either you can write in terms of minus Ra or minus Rb. He is nothing but he himself is giving you 12.5 liter square mole square minute. This is the unit for K, because it's a third order reaction, which will have a what do you call dimensions of concentration power 1 minus 3. Therefore, concentration square into time, right? So that is what time power minus 1. CACB square. This is the forward. minus 1.5 minute inverse CR. So forward reaction is third order, backward reaction from this is first order, correct? Because minute inverse it will comes only for the first order. So RA is having a unit of mole per liter into minute, right? So what is the problem? Is to take place in a 6 liter steady state mixed flow reactor. So volume is given 6 liters. Two feed streams, one containing 2.8 moles of A per liter and the other containing 1.6 mole B per liter. So he's giving you mole B per liter. That means volumetric flow rate or molar flow rate is giving you. Am I right? He's giving you molar flow rate. Am I right? Are to be introduced at a equal volumetric flow rate. So the molars is giving you, but is going at a equal volumetric flow rate. 75% conversion of the limiting component is desired. What is the limiting component? If now in this reaction A and B, one of the thing may be a limiting reactant, whereas the other reactant can be an excess. So he's asking you 75% of the limiting component is what is desired. Generally, in any reaction, your conversion will all be based on the limiting component, not the excess component, right? How much the limiting component is converted, right? So he is giving you figure. What should be the flow rate of each stream? He's asking you to get this conversion. What is the flow rate of each stream? Assume that a constant density is throughout. So here, one important thing is he is giving you liquid phase reaction. Therefore, it is assumed that it is having a constant density because liquid you cannot compress. So even if he is not giving you this, just by looking at this particular thing, you can take it as expansion is 0. For sometimes he is not giving you this liquid phase reaction. He is just telling you that an elementary reaction and then giving. Then if he is giving you this constant density, then also you can take it as 0 because the moment it is constant density, that means that it is a liquid phase reaction, right? This is the diagram. 6 liters of volume of mixed reactor is there. Ca0 is 2.8 moles A per liter. Cb0 is 1.6 moles B of liter. You are having a equal volumetric flow rate of A and B. That is what is giving you to be introduced at a equal volumetric flow rate. So VA, VB is equal to V, whatever it is, equal volumetric flow rate. For this kind of thing, 75% conversion of B or limiting component is desired. So for this kind of thing, what should be the flow rates? That is what he is asking you. So first you have to understand the problem, what is giving you, right? Then you can do just write the given data, what is given. Ca0 is 2.8. Cb0 is 1.6. He's putting dash. I'll tell you why they put dash. Now the concentration of the component in the mixed stream. The components, because A and B is going in both adding in the reactor. So what will happen? It is going in a mixed reactor. So Ca0 becomes 1.4 moles per liter. Cb0 becomes 0.8 and Cr0 is initially 0. Yeah, can anyone notice what is happening there? How this 1.4 and 0.8 came? He is giving 2.8 and 1.6. Why you are taking Ca0 as 1.4 instead of 2.8? Why Cb0 is taken as 0.8 instead of 1.6? That is why he is giving dash dash here. Yeah. Can anyone tell that? Yes, ma. Anyone?
So stoichiometry it is given A plus
It is
2B.
given as A plus 2B. So
we have to divide by 2 for B.
Only
And
B.
for A,
Then why you divided A also? Yeah, some answer, whether it is correct or wrong, at least I appreciate his effort. Yeah, good. So you are telling that it is stoichiometry A plus 2B. So since minus RA is half times RB, you are taking half. But why both are making half? Because from this, if you are telling only one thing should be half, right? Why both are half? Yeah. Any other? Any other? Any other? Yeah, you make a try so that it. This is very important when there are 2 streams or 3 streams going. So I'll give you what is the answer. Now you see how many liters is going inside per unit time. A is 1 liter and B is also 1 liter, right? Correct? Emma, 2.8 and 1.6 moles of A, moles of B per liter. So A is going 1 liter. B is also going 1 liter. Forget about what is the concentration. So A and B streams, 1 liter of A and 1 liter of B is going. Correct. So how much is the total volume which is going per unit time? 2 liters. Correct. For 2 liters, you are having 2.8 moles of A. But you are writing per liter, therefore divide by 2. Since he is giving you equal moles, it is being introduced. So 1 liter, 1 liter. For every time, 1 liter, 1 liter, 2 liters is going per unit time, whatever may be the time, right? So that is why you are making as half. Because in 2 liters, you are having 2.8 moles. So if you want for 1 liter, what is the concentration? It will be by 2. It is just like adding sugar water of concentration something of 1 liter of sugar water with some concentration with 1 liter of normal water. If you add it, the amount of sugar is going to be same in the 2 liters, but the concentration of A will drop because you have to divide by 2 because it is diluted. Here also it is getting diluted because liters of B is something else, liters of A is something else. So when you add 2 liters is there in the 2 liters, this concentration, if you are having for 1 liter, it will be by 2. Yeah, does it make sense? This particular logic. If you understand this, the rest of the problem is very easy. Only the difficult part is how you are getting this 0.2 and 0.8. So even B also there is 2 liters. Entire thing is 2 liters. In 2 liters, you are having 1.6 of B. So how much is B per liter? It is 0.8. Right? Does it make sense? Does it make sense? Okay. So from these figures, we know that Ca naught is 1.4, Cb naught is 0.8. So what is the limiting reactant here? B. And what is the excess reactant? A. So you are asked to calculate 75% of limiting reactant. So limiting reactant is nothing but B. Right? So that is what is giving you. These numbers show that B is the limiting component. So 75% conversion of B is to be attained. So you know that epsilon is 0 because it is a liquid phase reaction. So composite, what will be the composition? Ca is 1.6. Ca is 1. Let us calculate for Cb first. Cb 75% conversion is required. So you can calculate Cb because Cb is Cb naught into 1 minus Xa. Xa is known. So from that you can calculate Cb. Cb is 0.2. Right? Cb is 0.2 moles per liter, or for a 75% conversion, this will be your final B. What will be the A? A is initially is 1.4 minus, you know that how much is B minus RB by 2. Minus RA is nothing but minus RB by 2. So RB, you know how much is the thing, divided by 2 will give you something, and 1.1 moles of liters. So Ca will have this much at the 75% conversion. Cb will have this much, and CR will have this much, right? CR will have this much from that particular figure. So writing in terms of rates, minus RB is 2 times minus RA, or minus RA is half times minus RB. So we know that 2 times into 1.5, because this is the rate expression which is giving you 12.5 CACB square 0.8. This is the minus RA. So just I'm writing that 2 times 12.5 into, because T this is 2 CACB square minus 2 times 1.5 CR. So if you substitute all the things, you know what is CA, what is CB, and what is CR, then you are landing with minus RB is this much, because limiting component only we are writing, not with the excess component. Therefore, minus RB is this much. So you know that there is no density, and the performance equation is for mixed reactor. Therefore, you take the mixed reactor, tau is V by V naught, is nothing but CB naught minus CB by minus RB. Now we want what is the volumetric flow rate? Tau is nothing but V times RB by CB naught minus CB. So if you substitute all in the same units, V is in terms of liters, RB is also in terms of liters, and CB naught is also in terms of liters, then you are left with 6 liters per minute. So volumetric flow rate is 6 liters per minute, but actually this is the total volumetric flow rate. That is what we are putting. So each volumetric flow rate, because VA and VB, 2 streams should go. The total volumetric flow rate is equally volumetric flow rate. Therefore, total is 6. So equal in the sense 3 liters per minute of each of 2 streams. Then it becomes 6 liters per minute. So total volumetric flow rate. Yeah, I don't know whether you understood this logic or not. I'll just put it. Just try to do. I'll give you 2 minutes. Just copy down in your thing. Yeah, any doubt here? Emma? Any doubt? You understood? There are 2 things here. One is how you are getting 0.6, 1.4. And the last one is why you are writing 3 liters per minute of each stream. Rest of the thing is similar, because this expression is given. Here one more thing is what is limiting component, you have to calculate from this. Whichever concentration is less, that is the limiting. Whichever concentration is more, that is the excess. Yeah. Anything, ma? If this is true, then we can go for one PFR problem. Yeah, since it is a worked out problem, I am not writing anything here. Please try to do it, because the moment I start doing it, it takes long time. So let us do some problem on plug flow reactor. Yeah, please write this problem in a plug flow reactor. Yeah, please write this problem. A homogeneous gas reaction, A gives 3R, has reported to at 215 degrees centigrade. Is giving you the temperature also. Minus RA is 10 power minus 2, CA power half. So minus RA unit is giving you mole per liter second. Find the space time needed for 80% conversion. XA is giving you 50% A and 50% inert. So it is not a pure A which is being present, right? To a plug flow reactor operating at 215 degrees centigrade and 5 atmospheres. So is giving you both temperature and pressure is giving you, and is giving you CA0 also. What is asking you to calculate? For 80% conversion, what is the space time tau required? We know that tau by CA0 is integral 0 to XA
dxa by minus RA. That is the expression for plug flow reactor. So you know it is a gas phase reaction. A is giving you 3R. So that itself, you know that you should keep expansion factor, and even is giving you gas phase also. Yeah, please try to doing that. Take an plug flow equation and then do. So 50% A, 50% inert. So what will be the expansion factor? Put the tabular column what I put. A, R, inert, and then total. XA is 0, XA is 1. Yeah, try calculating that. How much expansion factor you are getting? It is 50%. Therefore, 3 minus 1 by 3. 3 minus 1 divided by 1. Am I right? So this is okay. Sorry. This is 50% inerts is present, right? So if you do that, you get expansion factor of 1. Are you getting the expansion as 1? Because it is A is giving you 3R. So expansion factor 1 means it's not no need for you to take, because it is just like yeah, you can see here tau by CA0 is integral 0 to XA of dXA by minus RA. This is the plug flow equation. We know that CA0 minus RA is already is giving you minus RA. You substitute that. So minus RA, CA is nothing but CA0 into 1 minus XA whole power half. So K CA0 half 1 minus XA by 1 plus epsilon A XA whole power half. Epsilon A you substitute as 1. Therefore, you are left with CA0 power half by K integral 0 to 0.8. Why it is 0 to 0.8? Because you want only 80% conversion. So the integral will be 0.8, 1 plus XA by 1 minus XA whole power half into dXA. This integral you have to evaluate for a different XAs. So calculating this integral for this is very difficult. That is why either you can go for a graphical way or a numerical way or analytically. That's up to you how you want to do. The simplest thing is graphical. Graph what you do, you assume XA as 1, that is 0.1, that is 10%, and then substitute in this, calculate the integral, and then put this value, right? So all the 3 methods he is illustrating. XA is this 1 minus XA by 1 minus 1 plus XA by 1 minus XA whole power half. He is taking some different XAs. So 0 means this value is 1. 0.2 means 1.5 like this. This is one method. The other one is graphical method. Graphical method again 1 minus XA by 1 plus XA whole square. You calculate and then draw with the XAs. Then you have to find the area under the curve. So for that you can take a center point of this and this. Calculate this and then try to calculate the area of this rectangle, or you can calculate the area under the curve. That's up to you how you want to do it. So average height, you know, height into width will give you the area. That is nothing but area of a rectangle, right? So any method you can do. You can do a numerical integration also by using Simpson's rule. I don't think you require me to tell about what is Simpson's rule. Simpson's rule again, there will be 1 plus 4 times 2 times, all that you have to calculate, and then you can calculate this entire integration. This is by using Simpson's 1/3 rule or whatever it is, right? So any method you can do either analytically or numerically or graphically. So find out the value that will give you, if it is an analytical solution, you try to find out this what you call a solution for this by using the calculus. We know that calculus, what is that calculus? So this, if you integrate it, you get this particular thing, arc sine XA. Then the value of it is 1.13. 1.13. So from that we know that tau is tau by CA naught. Already we substitute in this to calculate because this is what you are calculating, and then you substitute this entire thing, then you get tau. Then you get tau, right? That is what he's asking. The tau will be, yeah, tau is 0.06 this into 1.33. This is the integration value, and this is the value. So 33.2 seconds is required for this reaction to convert to 80%, right? So any of the method you can use, that's up to you. But always it is better to draw a graph. That is much simple, right? So try to do these three problems. More than that, any problem is like that. So try to do this problem also. It is a worked out problem. Some problems I might have given in the what do you call this as a tutorial also. So there are three problems for this, three problems for mixed reactor. Based on this, you can do some of the problems in tutorial, and the rest of the problem where one reactor is combined with another reactor, that we'll teach in the next class. Okay. So
Sir,
I'll stop here. Yeah.
Sir, in a plug flow reactor, length is important for conversion, isn't it, sir?
Length is important.
For conversion,
Yes, yes. I'll just call you. Yeah. Please go ahead. Some of you, yeah.
Sir, won't we consider length for plug flow reactor?
Volume, length times diameter will become volume, right? Because diameter is same. So length is nothing but volume now, correct? Because pi by 4 d square into L becomes the volume of the cylinder.
Okay, sir.
Now, did I answer your question? No, I didn't understand what you asked. You are asking about the length,
design
right?
equation, sir.
Yeah, length, right?
Yes, sir.
So volume is nothing but length, right? What is volume of a reactor? Cylinder. 4 by 3 pi r square L, right? Pi r square is nothing but the cross-sectional area that is going to be same because volume, this reactor is having a same diameter. So this diameter, cross-sectional diameter is same. So the length. So based on the length, your volume will change. Absolutely true. As you tell, length is important because we are considering the volume, right? So volume is nothing but length there. Because pi by 4 d square, that is the cross-sectional area is same because the diameter of the pipe is same. Yeah, correct.
Yes, sir. Okay, sir.
If there is a tapered pipe, then the volume will change with the length, definitely, because the diameter is going to change. But generally, this plug flow reactor is nothing but diameter same. It's a straight pipe. Okay. Yeah. Any other?
Sir, another doubt. So can we say that the space-time is equal to the length because the amount of time required for a 80% conversion or
One
conversion?
second. Tau by CA naught is V by FA naught, right? The V by FA naught is having the same unit, is a unitless dimensions. Tau by CA naught is equal to XA by minus RA. So the units, it should be matching. But you cannot tell that the length is equal to the space time because space time is having a unit of time, whereas length is having a unit of meters. So you cannot compare both. But V by FA naught is tau by CA naught. The units are same. The expression unit will be same, but that does not mean that V is equal to tau is equal to V. Yes.
Okay, sir.
You understood what I told? Is it your problem clear?
Yes, sir.
V by CA naught, tau by CA naught is V by FA naught. That does not mean that numerator is numerator equal to numerator, denominator is equal to denominator. They are different entities because both the expression will have the same unit. Numerator and denominator together will have the same unit. Yeah. Yeah. Any other? Good question. Yeah. Even the other question is very good. Length. Now I'm just thinking about your question. Yeah, that's a very good question because the length, volume is nothing but the length because the diameter is C. Yeah. Any other, ma? Good questions. So I think it is already 9:30. I stopped the recording. Thank you for joining. You try to do some problems. If you do the problems, you will get a lot of doubts. And then we'll discuss that problems in the next class. Okay. Thank you. I stop the recording. Yeah. Tomorrow